Hi, my name is Matthew, and I am a CSS instructor, and I'm teaching a course called The Ultimate Speed Limit, which is about Einstein's theory of relativity. And now, in order to understand Einstein's theory of relativity, one must first understand the ideas of classical relativity. And the ideas of classical relativity lie in the concept of speed. Now, most of us understand that speed is a distance covered per unit time. For example, a car driving along the highway at 60 miles per hour is covering 60 miles every hour. But the important part here is that speed only makes sense when you're talking about it with respect to something else. So a car might be moving at 60 miles per hour with respect to the ground, but with respect to a car that it's passing by along the highway, it might only be going 5 miles per hour. And this concept is captured in what's called a reference frame. And a reference frame is simply an object's or an observer's perspective on the universe. So all speeds are measured in a given reference frame. Okay? So it's equally valid to say that my hand is moving through this room at 1 mile per hour in the room's reference frame, as it is to say that the room is moving past my hand at 1 mile per hour in my hand's reference frame. So, for example, I'm sitting here in this chair, sitting still in the reference frame of the room, but I'm revolving around the Earth at 1,000 miles per hour with respect to the Earth's core, and the Earth is revolving around the Sun at 19 miles every second in the Sun's reference frame, and you could even go so far as to say that I am going 137 miles every single second around the center of the galaxy in the galaxy's reference frame. But we don't feel any of this movement because we are sitting still in this room's reference frame. And now this idea of relative velocities is captured in what's called classical relativity. But during the 1800s and 1900s, two scientists by the name of Maxwell and Einstein studied electricity and magnetism and found that there's something that does not obey classical relativity. And that something is light, which they found that always moves at this particular speed called c, which is 186,000 miles per second, with respect to everything. So no matter what reference frame you're in, light is always moving at the same speed. Now, this creates a lot of interesting side effects, the coolest of which is called time dilation. Now, when you have an object moving at a sizable portion of the speed of light with respect to another object, time for that object will actually slow down in relation to the other object's reference frame. So the clocks on this object will literally tick slower. Other effects include things called length contraction and loss of simultaneity, where length contraction is a sort of shortening of objects as you speed up, and loss of simultaneity is the fact that events don't always occur at the same time that they would if classical relativity held and special relativity did not. It took a while for the scientific community to understand these concepts, but now that we have done so, we can do such things as correct for the time dilation effects in GPSs and understand the trajectories of objects in outer space when we're trying to go to places like the Moon and Mars, and understand things like cosmology on the galactic scales where we can understand the properties of the universe given these really strange effects in time dilation and length contraction and the fact that the speed of light is constant in every frame.